Hey guys, in today's lesson we're going to talk about properties of logarithms, which is found in section 7-4 of your book. Our objective is to use the properties of logarithms. Okay, just a few properties. The product property is when you have a log base, basically a log of some base and a product. You can split that product by keeping the same log base and then just adding the two components of the product, or however many components of that product. Similarly, with a quotient property, when you are dividing, you will simply keep the same log base and subtract the numerator from the denominator. And then power product is when you have a base raised to a power. So your log base, and then you have a base raised to a power. That power then becomes the coefficient of the log base, and you keep the regular base in its current position. So let's kind of take a look at what this is going to be like in our example. All right, so it says, what is each expression written as a single logarithm? So it says log base 4 of 32 minus log base 4 of 2. So it's subtraction, so the first thing we should think is division. So what we should have, and because they also have the same base, we'll keep log base 4. And then the first one will be the numerator. The second will be the denominator. Now we can reduce 32 over 2 to be log base 4 of 16. And I know it says what is each expression written as a single logarithm, but in this case, because they're just numbers, we can actually go ahead and solve. So at this point, remember, it's kind of like saying 4 to the what power equals 16, right? Because log is bay. And really I should put E on the other side so that you can see it better. Okay, so that's how we got 4, which is the base, raised to the x power, that's the exponent, right? The exponent and the x is equal to the answer, which is 16. So we're asking ourselves 4 to what power equals 16, and our answer is going to be 2. All right, let's look at the second one. The first thing that I noticed is that they have a common base, which is good, but then I also noticed that I have powers going on here, and I also have products. So let's go ahead and first deal with the powers. So this is really going to be log base 2 of x to the 6th plus log base 2 of y to the 5th. And then because it's addition, that addition is going to make it multiplication. So then this becomes log base 2 of x to the 6th, y to the 5th. And we can't break it down further because those are variables. So let's take a look at our try. So again, what is each expression written as a single logarithm? Okay. All right, so the first one, we have log base 4 of 5x plus log base 4 of 3x. Again, they have the same base. So we're going to keep log base 4. And addition tells us it's really multiplication. So this becomes 5x times 3x. But 5x times 3x, we should know, is log base 4 of 15x squared. And we would actually leave it at this point. I know you may feel tempted to want to put the 2 back in the front, but this is actually our final answer. And we can't break it down further. All right, looking at the second one, again, they have the same base. So I see a power, and I also see subtraction, which I know is going to mean division. So let's deal with the power first. This is going to be log base 4 to the 6th squared minus log base 4 of 9. Okay, then from there, I can actually go ahead and find 6 squared, which I know is 36. I'm going to cross that out and write 36. And then we know subtraction really means division. So this is going to be log base 4 of 36 over 9. 36 over 9 is really 4. So again, we're asking ourselves that question, log is bay. So to write it correctly, this would be 4 to the x equals 4. So what power can 4 be raised to get 4? It must be 1. All right, let's keep going. All right, so in example 2, it says, what is each logarithm expanded? So now we're going back and expanding, okay? What we should see is that, well, no, that's really about it. Okay, so the first one we have 4x over y. The first thing that I see is division. So I'm going to deal with the division first. So this is going to be log. We don't see a base, so that must mean that it's 10. And remember, when it's 10, we don't have to write it. So this is log 4x minus log y. And then I see the 4x that needs to be broken up. Remember, that's a product, and products are shown as addition. So this becomes log of 4 plus log of x, and then don't forget the original minus log of y. And we're done with that one. All right, so the second one, again, the first thing I see is division, so let's deal with that first. This one has a base, so this is going to be log base 9 of x to the 4th minus log base 9 of 729. And again, this x is to a power, so that 4 needs to come to the front. Remember that 4 comes to the front. So this becomes 4 log base 9 of x minus, and again, this piece here, we're going to do some work on it. Remember, that's log is bay, right? So this is really, I'm going to put it kind of in parentheses, this is really 9 to the x equal to 729. So 9 to what power is going to give us 729? Hopefully they have the same power. And actually x is going to be 3, because 9 times 9 times 9 is going to give you 729. So our actual final answer is 4 log base 9 to the x minus 3. And we are done with that one. Let's look at our try. It says, what is each logarithm expanded? So again, I notice the first thing I see is division. They have a common base, so this is log base 3 of 250 minus log base 3 of 37. Okay. All right, also, now what may not seem so evident is within these large numbers, 250 and 37, what you're actually trying to look for is, because the base is 3, you're trying to look for a perfect cube. And actually within 250 is actually 2 times 125. And 125 has a perfect cube of 5 times 5 times 5. All right, so if we keep going, what this will produce then, because it's a product, right, and product we know is addition, that's going to give us log base 3 of 2 plus log base 3 of 125, and still minus log base 3 of 37, because you can't break 37 down. Okay, and remember 125 is really 5 cubed. So what we're going to have to do is move that power to the front. Okay, so this is then finally going to produce log base 3 of 2 plus 3 log base 3 of 5, and then finally minus log base 3 of 37. I know that one was a challenge, but again, you want to try and look for whatever the base is, look for its perfect root if you have large numbers, so that you can kind of break it down further. But this is actually the expanded version of that log. All right, let's keep going. All right, on the second one, the first thing I notice is that this is a product. Now, don't get confused and think that you need to move the 5 to the front, because remember, the 5 is technically only touching the x. It's not touching 9x as if it's in parentheses, okay? So with that being said, we need to split up the product first and get log base 3 of 9 plus log base 3 of x to the 5th. Okay, log base 3 of 9, think about it. 3 to the what power gives us 9? That's going to be 2. So this is really 2 plus, and then we need to move this 5 to the front. So this gives us 5 log base 3 to the x. And we are done with this problem here. All right, let's keep moving. All right, so now we're going to start talking about a change of base formula, and we use this whenever we don't have a common base, okay? And even if you do have a common base, it makes it a lot easier, but specifically if you don't have a common base, then you can kind of throw it into the calculator. So I'm going to show you what I mean. All right, so log base 81 of 27, okay? The first thing that we want to do is we're going to want to, because we don't want to think of like, hey, 81 to what power gives you 27. In fact, actually, I guess we could do that. Remember, because log is bay. So really, this could be 81 to the x power equals 27. You would notice that they have a common base of 3. Remember, 81 is 3 to the 4th, and 27 is 3 to the 3rd. So this is really 4x equal to 3, divide by 4. So x equals 3/4 or 0.75. That's one way of doing this problem. The other way is to just take the log of the outer number divided by the log of the inner number. So this is going to be rewritten as log of 27, right? As, you know, regular base 10 over log of 81. If you typed log of 27 into your calculator and divide that by log of 81, you will get 0.75. So because it shares a common base of 10 and it also shares a common base of 3 on the other one, it works, okay? But you'll see in the second one we don't have a common base, so our only choice is to use the change base formula. Okay, so let me kind of get rid of some of this. Just going to get rid of the stuff on this side. Okay, so on the second one we have log base 5 of 36. 5 and 36 do not share a common base at all. So the only thing we can do is take the outer one and divide it by the inner one. So this is going to be log base 36 over log base 5. If you throw that into your calculator, you're going to get about 2.23. And we are done. Okay. All right, let's look at the try. All right, so it says, what is the value of each expression? So again, we want to see if they have a common base. So 8 and 32, yes, they do share a common base. Remember, log is bay. Log is bay. So the base is 8 raised to the x power is supposed to give us 32. This base that they share is 2. So 2 cubed to the x equals 2 to the 5th. Here we're going to end up getting, after the bases is the same, we'll get 3x equals 5. So x equals 5/3 or 1 2/3 or 1.67. Okay. On this second one, however, they don't have a common base. So we're just going to take the outer and divide by the inner. So this is going to be log of 18 over log of 4. We throw it into the calculator and we'll get about 2.09 if we round to the nearest hundredth. And guys, we are done. If you have any questions, please be sure to let me know or come in for tutoring.